Constellations go back to prehistory. They are an outline or pattern that man has assumed reference to represent a person or creature or God. People use them to relate stories of beliefs or creation stories. These all lasted into the 20th century. Then the recognition changed significantly. Science changed the sizes, shapes. Some became popular and others dropped into obscurity. Some stayed secluded to a single culture or nation. Some were split into two, and some had pieces taken from one and another to form a third. Traditionally, there were 48 constellations recognized by Ptolemy in Almagest and by Aratus' work Phenomenon, although both of these probably originate by serial centuries. Constellations in the far south were added between the 15th century until the 18th century. The 12 ancient constellations belong to the zodiac, straddling the ecliptic, which the sun, moon, and planets all traverse. The true origins of the zodiac remain historically uncertain. Its astrological divisions became prominent in 400 BC in Babylonian or Chaldean astronomy. In 1922, it was accepted of the modern list of 88 constellations, and in 1928 it was adopted as the official constellation boundaries that covered the entire celestial area. Other star patterns, called asterisms, are not full constellations, but part of a larger set of stars and are used to navigate the sky. With the change of the constellations, some of these asterisms are now shared between two constellations. Some examples of these are Pleiades, Hyades within the constellation Taurus, and the false cross split between the southern constellations Carina and Velas, or Venus's mirror in the constellation of Orion. One of the most well-known is the Big Dipper, composed of the 7 brightest stars within the area within the constellation Ursa Major. A constellation or star viewed from a particular latitude that never sets below the horizon is termed circumpolar. Some of the history of individual areas are quite interesting. In Mesopotamia, inscribed stones and clay writing tablets from Mesopotamia, which is modern Iraq, dating to 3000 BC, provide the earliest generally accepted evidence for humankind's identification of constellations. It seems that the bulk of Mesopotamia constellations were created within a relatively short interval from around 1300 to 1000 BC. Mesopotamia constellations appeared later in many of the classical Greek constellations. In ancient Near East, the oldest Babylonian catalogs of stars and constellations date back to the beginning of the Middle Bronze Age. Most notably, the 3 stars, each text, and the Mul Apen, an expanded and revised version based on more accurate observations from around 1000 BC. However, the numerous Sumerian names in these catalogs suggest that they built on older but otherwise unattested Sumerian traditions of the early Bronze Age. The classical zodiac is a revision of Neo-Babylonian constellations from the 6th century BC. The Greeks adopted the Babylonian constellations in the 4th century BC. 20 Ptolemaic constellations are from the ancient Near East. Another 10 have the same stars but different names. Some scholars have interpreted some creatures mentioned in the book of Ezekiel and Revelations as the middle signs of the 4 quarters of the zodiac, with the lion as Leo, the bull as Taurus, the man as Aquarius, and the eagle standing in for Scorpio. The book of Job in 9:9 and 38, chapters 31 through 32, is assumed to make reference to the constellations as well. Job 9:9 says, "He made the bear, Orion, and the Pleiades, and the chambers of the south." Job 38:31 through 32 says, "Can you bind the cluster of the Pleiades, or loose the belt of Orion? Can you bring Mazzaroth in its season? Or can you guide the great bear with its cubs?" And Job 33 also says, "Knowest thou the ordinance of heaven? Canst thou set the dominion thereof in the earth?" In classical antiquity, there is only limited information on ancient Greek constellations, with some fragmentary evidence being found in the work and days of the Greek poet Hesiod, who mentions the heavenly bodies. Greek astronomy essentially adopted the older Babylonian system in the Hellenistic era, first introduced to Greece by Eudoxus of Cnidus in the 4th century BC. The original work of Eudoxus is lost, but it survives as a verification by Aratus, dating to the 3rd century BC. The most complete existing works dealing with the mythical origins of constellations are by the Hellenistic writer termed Pseudo-Eratosthenes and the early Roman writer styled Pseudo-Hyginus. The basis of Western astronomy as taught during the late antiquity until the early modern period is the Almagest by Ptolemy, written in 2nd century. In the Ptolemaic kingdom, native Egyptian tradition of anthropomorphic figures represented the planets, stars, and various constellations. Some of these were combined with Greek and Babylonian astronomical systems, accumulating the zodiac of Dendera. It remains unclear when this occurred, but most were placed during the Roman period between the 2nd to 4th centuries AD. The oldest known depiction of the zodiac showing the all now familiar constellations, along with some original Egyptian constellations, deacons, and planets. Ptolemy's Almagest remained the standard definition of constellations in the medieval period, both in Europe and Islamic astronomy. Ancient China. Ancient China had a long tradition of observing celestial phenomena. Non-specific Chinese star names, later categorized in the 28 mansions, have been found on oracle bones from Anyang, dating back to the Middle Shang dynasty. These constellations are some of the most important observations of Chinese sky, attested from the 5th century BC. Parallels to the earliest Babylonian, Sumerian star catalogs suggest that the ancient Chinese system did not arise independently. 3 schools of classical Chinese astronomy in the Han period are attributed to astronomers of the earlier Warring States period. The constellations of the 3 schools were conflated into a single system by Shen Hua, an astronomer of the 3rd century, the Three Kingdoms period. Chen Hua's work has been lost, but information on his system of constellation survives in Tang period records, notably by Quatuan Zeta. The earliest extant Chinese star chart dates to that period and was preserved as part of the Dun Huang manuscripts. Native Chinese astronomy flourished during the Song dynasty, and during the Yuan dynasty became increasingly influenced by medieval Islamic astronomy. As maps were prepared during this period on more scientific lines, they were considered more reliable. A well-known map from the Song period is the Suzhou astronomical chart, which was prepared with carvings of stars on the planisphere of the Chinese sky on a stone plate. It is done accurately based on observations, and it shows the supernova of the year 1054 in Taurus. Influenced by European astronomy during the late Ming Dynasty, more stars were depicted on the charts, but retaining the traditional constellations. New stars observed were incorporated as supplementary stars in old constellations in the southern sky, which did not depict any of the traditional stars recorded by ancient Chinese astronomers. Further improvements were made during the later part of the Ming Dynasty by Zhu Guangqi and Johann Adam Shaw von Bell, the German Jesuit, and was recorded in Chongzhen Lishu. Traditional Chinese star maps incorporated 23 new constellations with 125 stars of the southern hemisphere of the sky, based on the knowledge of Western star charts. With this improvement, the Chinese star chart was integrated with the world astronomy. In early modern astronomy, historically, the origins of the constellations of the northern and southern skies are distinctly different. Most northern constellations date to antiquity, with names based mostly on classical Greek legends. Evidence of these constellations has survived in the form of star charts, whose oldest representation appears on the statue known as the Farnese Atlas, based perhaps on the star catalogue of the Greek astronomer Hipparchus. Southern constellations are more modern inventions, sometimes as substitutes for ancient constellations such as Argo Navis. Some southern constellation had long names that were shortened into more usable forms. An example is Musca Australis. It simply became Musca. Some of the early constellations were never universally adopted. Stars were often grouped into constellations differently by different observers, and the arbitrary constellation boundaries often led to confusion as to which constellation a celestial object belonged to. Before astronomers delineated precise boundaries, which started in the 19th century, constellations generally appeared as ill-defined regions of the sky. Today, they now follow officially accepted designated lines of right ascension and declination, based on those defined by Benjamin Gould in Epoch, 1875, in his star catalog, Euromitra, Argentina. In 1603, the star atlas Euromitra of Johann Bayer assigned stars to individual constellation and formalized the division by assigning a series of Greek and Latin letters to the stars within each constellation. These are known today as Bayer designations. Subsequent star atlases led to the development of today's accepted modern constellations. Origin of the southern constellations. The southern sky, below about 65 degrees declination, was only partially catalogued by ancient Babylonians, Egyptians, Greeks, Chinese, and Persian astronomers of the north. Knowledge that northern and southern star patterns differed go back to classical writers who describe, for example, the African circumnavigation expedition commissioned by Egyptian pharaoh Necho II in 600 BC, and those of Hanno the Navigator in 500 BC. However, much of the history was lost with the destruction of the Library of Alexandria. The history of southern constellations is not straightforward. Different groupings and different names were proposed by various observers, some reflecting national traditions or designated to promote various sponsors. Southern constellations were important from the 14th to 16th century, when sailors used the stars for celestial navigation. Many of the 88 constellations in this region first appeared on celestial globes developed in the late 16th century by Petrus Palancius, based mainly on observations of Dutch navigators. These became widely known through Johann Bayer's Star Atlas of 1603. 17 more were recreated in 1763 by French astronomer Nicolas Louis de Lacaille, appearing in his star catalog published in 1756. The 88 modern constellations. A general list of 88 constellations was produced for the International Astronomical Union in 1922. It is roughly based on the traditional Greek constellations list by Ptolemy in his Almagest in the 2nd century and Aratus's work Phenomenon, with the early modern modifications and additions, most importantly introducing constellations covering the parts of the southern sky unknown to Ptolemy, by Petrus Plancius, Johannes Hevelius, and Nicholas Louis de Lacaille, who named 14 constellations and renamed a 15th one. De Lacaille studied the stars of the southern hemisphere from 1750 until 1754 from Cape of Good Hope, when he was said to have observed more than 10,000 stars using a 0.5-inch refracting telescope. In 1922, Henry Norris Russell produced a general list of 88 constellations and some useful abbreviations. However, these constellations did not have clear borders between them. In 1928, the International Astronomical Union formally accepted 88 modern constellations with continuous boundaries along the vertical and horizontal lines of right ascension and declination developed by Eugene Delporte that together cover the entire celestial sphere. This list was finally published in 1930. Where possible, these modern constellations usually share the names of their Greco-Roman predecessors, such as Orion, Leo, or Scorpius. The aim of this system is area mapping, the division of the celestial sphere into continuous fields. Out of the 88 modern constellations, 36 lie predominantly in the north sky, and the other 52 are predominantly in the southern. The boundaries developed by Delporte used data that originated back to Epoch 1875, which was when Benjamin Gould made his first proposal to designate boundaries for the celestial sphere, a suggestion upon which Delporte would base his work. The consequence of this early date is that because of the precession of the equinoxes, the borders on a modern star map, such as Epoch, are already somewhat skewed and no longer perfectly vertical or horizontal. This effect will increase over the years and centuries to come. Dark cloud constellations. The Great Rift, a series of dark patches in the Milky Way, is more visible and striking in the southern hemisphere than in the northern. It vividly stands out when conditions are otherwise so dark that the Milky Way's central region casts shadows to the ground. Some cultures have discerned shapes in these patches and have given names to these dark cloud constellations. Members of the Inca civilization identified various dark areas in the Milky Way as animals and associated their appearance with the seasonal rains. Australian Aboriginal astronomy also describes dark cloud constellations, the most famous being the emu in the sky, whose head is formed by the coal sack, a dark nebula instead of stars. Constellation families. These are a collection of constellations sharing some defining characteristics such as proximity, common historical origin, or common mythological theme. In Western tradition, most of the northern constellations stem from Ptolemy's list, which in turn has roots that go back to Mesopotamian astronomy. And most of the far southern constellations were introduced by sailors and astronomers who traveled to the south in the 16th through 18th centuries. Separate traditions arose in India and China. Donald H. Menzel, director of the Harvard Observatory, gathered several traditional groups in his popular account, The Field Guide to the Stars and Planets, published in 1975, and adjusted and regularized them so that his handful of groups covered all 88 of the modern constellations. Of these families, one, zodiac, straddles the ecliptic, which divides the sky into north and south. One, Hercules, has nearly equal portions in the north and south. Two are primarily in one hemisphere, heavenly waters in the south and Perseus in the north. The four are entirely in one hemisphere, Lacaille, Bear, and Orion in the south and Ursa Major in the north. The Ursa Major family includes 10 northern constellations in the vicinity of Ursa Major. This includes Ursa Major itself, Ursa Minor, Draco, Canes, Venatici, Butes, Coma Berenices, Corona Borealis, Camelopardalis, the Lynx, and Leo Minor. The zodiac is a group of 12 constellations: Leo, Virgo, Libra, Scorpius, Sagittarius, Capricornus, Aquarius, Pisces, Aries, Taurus, Gemini, and Cancer. These constellations move across the ecliptic, which is the path of the sun through the year. The Perseus family includes several constellations associated with the Perseus myth: Cassiopeia, Cepheus, Andromeda, Perseus, Pegasus, and Cetus. Cetus represents the monster that was sent to devour Andromeda. Except for Cetus, these constellations all lie north of the ecliptic. The group reaches from the near north celestial pole to a declination of 30 degrees. The Hercules family is a group of constellations connected mainly by their adjacency on the celestial sphere. It is Menzel's largest grouping and extends from a declination of 60 degrees to negative 70 degrees, mostly in the Western Hemisphere. It includes Hercules, Sagitta, Aquila, Lyra, Cyginus, Velpecula, Hydra, Sextans, Crater, Corvus, Ophiuchus, Serpens, Scutum, Centaurus, Lupus, Corona Australis, Ara, Triangulum Australe, and the Crux. The Orion family. On the opposite side of the sky from the Hercules family includes Orion, Canis Major, Canis Minor, Lepus, and Monoceros. This group of constellation draws from the Greek myth representing the hunter Orion and his two dogs, Canis Major and Canis Minor, chasing the hare, which is Lepus. Menzel also added the unicorn, Monoceros, for completeness. The Heavenly Waters draws from the Mesopotamian tradition associating the dim area between Sagittarius and Orion with the god Ah and the waters of the abyss. Aquarius and Capricornus, derived from Mesopotamia constellations, would have been natural members had they not already been assigned to the zodiac group. Instead, Menzel expanded the area and includes several disparate constellations and associated with water in some form. Delphinus, Equilius, Eridanus, Pisces Austrinus, Carina, Puppis, and Vela, which make up the boat, Pyxis, and Columba. Carina, Puppis, and Vela historically formed part of the constellation Argo, which in Greek tradition represented the ship of Jason. The Bear family collects several southern constellations first introduced by Petrus Plancius on several celestial globes in the late 16th century. Based on astronomical observations by the Dutch explorers Pieter Dirkzoon Keizer and Frederick de Houtman, the constellations were named mostly for exotic animals reported in the travels in the journals of that period and were copied in John Baer's influential Celestial Atlas. The group includes Hydrus, Dorando, Volans, Apis, Pavo, Grus, Phoenix, Tucana, Indus, Chameleon, and Musca. Baer labeled Musca as Apis the bee, but over time it was renamed. Baer's 12th new southern constellation, Triangulum Australe, was placed by Menzel in the Hercules family. The Bear family circles the south celestial pole, forming an irregular, continuous band. Because these constellations are located in the far southern sky, their stars were not visible to ancient Greeks and Romans. The Lacaille family comprises 12 of the 13 constellations introduced by Nicolas Louis de Lacaille in 1756 to represent scientific instruments. Together with Mensa, which commemorates Table Mountain, Mons Menza, in South Africa, where he set up his telescope. The group includes Norma, Circinus, Telescopium, Microscopium, Sculptor, Fornax, Calum, Horologium, Octans, Mensa, Reticulum, Pictor, and Antlia. These dim constellations are scattered throughout the far southern sky, and their stars were mostly not visible to the ancient Greeks and Romans. Menzel assigned Pyxis, the remaining locale instrument, to the Heavenly Waters group. We can see now how these have been rearranged throughout time and added to through the history. What we now call this used to be known by a different name. This is where the confusion comes in throughout history to present times. To end this, let's look at an old saying that we are made from stardust. We humans have the same building blocks that stars have: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Although the portioning differs, it is interesting that we have the same makeup as our heavens. It is of very great interest that the makeup of the stars are able to be mapped, and all of the major elements found in the human body are found across the stars in the Milky Way. This information is discovered due to each element emits distinct wavelengths of light from within a star. The light is collected in the near-infrared parts of the electromagnetic spectrum and disperses it like a prism. This reveals signatures of different elements in the atmospheres of stars. This shows us more of how the above is directly related to the below, and we may be the result of the in-between. This also gives us one more piece of the puzzle as to what NASA may be doing as they explore the layers below. I hope you enjoyed this information, and thank you.